welcome to this webinar, which is a preparatory webinar for the 11th CASSINI Hackathon, dealing with the topic of space data and water. Before we start the presentations, I would like to ask you to keep your questions for after the presentation, and you can put them in the chat, but also feel free to ask questions by opening up your camera and microphone, and then just directly address the presenter. So before we dive into the topic of today and the more details, let me first quickly give you an overview of the hackathon itself and the program of today's webinar. So let me share the screen. Yes, okay, so we know this. Today we have two speakers. Mr. Marnix Laanen from Water Insight. He will tell you something about the rip current detection with satellite data. And we have Mr. Friso from the Burg, who will speak about the Open Data Space Lab. It's a federated platform or system for data sharing, which could be used for during the hackathon. And then afterwards, we have some final remarks and some questions which you did not ask yet. So the hackathon is being organized by dotSPACE in collaboration with many Dutch partners. Water Insight, as mentioned, but also Rijkswaterstaat Innovation Quarter, the Nederlandse Voedsel- en Warenautoriteit, but also companies like S&T Group from Delft, and also the public partners like Innovation Quarter and the municipality of Noordwijk. All these representatives of these companies and organizations will be on site during the hackathon, and we will let you know when they are on site. So a little bit about the CASSINI program. The CASSINI Entrepreneurship Initiative is an initiative by the European Commission, and it's focused on supporting startups and SMEs to leverage space technology for various sectors. It offers, besides the hackathons, it offers funding, business acceleration opportunities to further build and scale businesses, but also to foster a robust space economy. The CASSINI Hackathon is a program specifically designed to make people familiar with space data and the various domains of application. Its focuses on Earth observation, satellite navigation, and satellite communication. And it ranges from prototyping to scaling up businesses, all with the help of the various elements of this CASSINI program. Could be funds, could be idea competitions, could be other grants. Then the specific challenges of the CASSINI Hackathon for April are three main categories. Like one is securing equitable and efficient water or access to water. The second is tracking and preventing water pollution. And the third one is disaster risk monitoring. And specifically for this webinar, we will focus on the challenge number 3 in terms of risk monitoring, but Marnix will tell more about it. In the other webinars, which we will host next week and the week after, the other two challenges will be addressed. So a little bit about the venue. The hackathon will take place at the Comet Lab. That's a newly developed building, a makerspace on the Space Campus in Noordwijk. Be aware it's an on-site event only. So if you have support, you're free to use platforms and so on, but participants must all be on-site. and the deadline for registration is the 19th of April. So what can you expect? Doors open at about 4 o'clock, Friday 24th. Then maybe some last minute team formation can be done, although you're free to use the Taikai or other channels to already get your team together. Then an official opening at about from 6 till 7, and from 7 till midnight you can start hacking. On Saturday, a full day of hacking, and mentors will be around, experts will be around. And on Sunday the 26th, so you have half a day of finalizing your prototype or product. Then you have to submit it at 3 o'clock. Then the jury will evaluate, and at about 6 we will announce the local winner. And the local winner will be competing with all the other local winners of the 9 other Cassini hackathons for the European first prize, which is another amount of funding, but also support from the Cassini ecosystem. And what do we do then after the hackathon? Of course, we have the award ceremony, which covers also monetary prizes, but also support packages. Afterwards, we will reach out to all the participating teams and introduce the follow-up program, which is guidance with collaboration of our partners. We will organize some workshop, and we will prepare the teams for the follow-up hackathon, which we organize early October. And this is a hackathon, same topic. It's related to the FIERS program, and FIERS is a business support program within the green and digital transition. And in this FIERS hackathon, is the working title, we will stimulate companies who have a bit more mature TRL, let's say starting point 4 to 5, and then can use this final hackathon as a validation for the application to the FIERS cascading funding program. So Cassini is a start, then you have some kind of a mentor guiding, and then October is the last hackathon, which should prepare you quite well for the FIERS program. This is all I have to say. So are there any specific questions regarding this aspect? I think we have time for 1 or 2 questions. I don't see it in the chat. In case no questions, then let me introduce Marnix, who will present the rip current detection system. Marnix, floor is yours.
Okay, thank you, Martijn. I'm Marnix Laanen from Water Insights. Yeah, and Water Insight is a company that does in water remote sensing, optical remote sensing of water quality monitoring, I have to say. So we use satellite data. That was the core thing that we started with 20 years ago. But of course, satellite data also needs validation. So we developed our own in situ spectrometers, that actually measure the same type of data as the satellites do. Using satellites for water quality monitoring is very practical for a number of reasons. It's easy to do trend analysis because you have a lot of data that goes back in time, for instance. You can have the spatial awareness because a lot of ground coverage is recorded simultaneously. It's easy because it's digital data from the start and often available in near real time to set up warning systems, for instance, for algal blooms. And it's very cost effective. We like to use Sentinel data, which is from the start downloadable for free. So that makes whatever we do as value adders relatively cheap if you compare it to traditional sampling, for instance. We have a number of markets where we operate We do a lot of research ourselves, so we also participate in for instance, Horizon projects, but we also sell our data and our instruments to researchers or research institutions. We have water managers as an important client for the instruments, even as standalone instruments, but also increasingly for commercial satellite applications. And relatively new market for us is dredging. So dredging companies that 20 years ago started laughing when we proposed we could monitor their sediment plumes because they didn't care at all. And in 20 years, they are made to care about what they are doing to the environment. So now they are back in the game for us. And the last vertical, as we call it, is aquaculture. So we are developing services especially for aquaculture, not only for risk assessment, again, the alga blooms, but also for longer term trend analysis, especially temperature, which is globally rising, which means that some of the aquaculture traditional products do no longer thrive in the environments they are cultivated at the moment. We're also looking into model predictions of shellfish growth using satellite-derived data as an input. So there's quite a bit you can do with Earth observation data, especially for water quality analysis. How does that work? In a nutshell, so we have a satellite that records a piece of the Earth's surface, which is in the, I guess you can see my mouse as well, but it's easy to track what I'm talking about. So you have a satellite image of water. It's usually very dark because water doesn't reflect a lot of the energy back to the sensors, which means that you have to do very good atmospheric corrections, for instance. But if you've done that, then you have what we call a reflectance spectrum. And from a reflectance spectrum, you can use algorithms or machine learning techniques to derive water quality parameters, as is shown in the last image. Lastly, for this slide, we developed two types of instruments. So we have a WISP station, which is a stationary instrument. It's install and forget instrument, as we call it, because it will measure completely autonomously. It will wake up every 15 minutes, do a measurement, send that back, all automatically, which is very handy because it also doesn't need cleaning or maintenance or whatever. So you can actually just put it somewhere, turn it on, and it will continue working all by itself. For more flexible solutions, we have a portable instrument. It's called the WISP Orca. As you can see, the lady in the movie is using it. The clip length is exactly the time it takes to actually get a measurement done. Next one, I think that if there are questions, people can put them in the chat, and then we will discuss them afterwards, right? So. I will just continue keeping on talking. I touched on this already a bit, but why is satellite data particularly interesting for water quality measurements? You get instant results, which is different from the traditional sampling, where it usually takes weeks or months to actually get results back from sampling from a laboratory. You have a synoptic view, so you can have really large surfaces at once, illustrated by this Maris image of the Danube Delta. Vast amounts of areas that you can collect at the same time. Maybe a bit interesting, talking about the Danube Delta. Using Earth observation, satellite pictures, you can also see what other people might not want you to see. So we have done a number of projects in the past where you have lakes that are cross-national, and then using satellite image, you can actually determine what another country is doing if that country isn't particularly helpful in wanting to tell what they are doing in terms of environmental activities. There is a large amount of historical data available. We've also done projects in regions of the world where there is very little background known. There's very little sampling done in the past. And then you can use satellite data to look back in time up to 10 years or even 20 if you have to. The satellite monitoring is very regular, so there's fixed times where these platforms can have a recurring visit, and again the costs are relatively low. How does that work for us as a company? So we have the image acquisitions. We need to do corrections, especially for the atmosphere. Then we look for certain features in the reflectance spectrum, and I think the most obvious one is for chlorophyll. We use band ratio algorithms that look for this dip in the reflectance spectrum and this peak that is adjacent to it. So that's an example of a physics-based algorithm. But increasingly, we also use machine learning techniques, random forest classifications, and then you get your water quality parameters like chlorophyll, suspended solids, transparency, the pigment of cyanobacteria, and ratios of that will tell you how much cyanobacteria are present. And that can go on to derived products such as warnings. Our tech stack to do this, I think I'm going too slow, am I? Maybe I need to speed up a bit and go to the actual thing at hand. So we did a project called Detecting Riptides from Satellite Images. Again, I can remind you we are at the Disaster Risk Monitoring webinar, so that's exactly what we did. So there are two approaches to detect these riptides. The first one classifies the beach morphology into places with an enhanced risk of riptide formations. We used very high resolution data and a machine learning approach, a random forest model for this. The second one, it was a bit more simple approach, looked for ongoing riptides by the sediment plumes that they produce. So more of a less automated way to look for riptides. Small safety briefing for people that have no clue what riptides are. Riptides is where the water flows back from the beach. So you have places, in most places, the waves will push water towards the beach, but of course that also has to go back, and that happens in a riptide. So where the foam is, you see the waves breaking, pushing the water towards the beach, but then at irregular intervals there will be a riptide where all the water flows back. Riptides is the most life-threatening activity that you can do in the Netherlands is go and swim at the beach, because most tourist fatalities are recorded when people drown, again mostly in riptides. If you might end up in a riptide, if you're swimming in the sea and suddenly you are transported towards the open sea in a very quick manner, you're probably in a riptide. Do not try to swim against the tide. You will always, you will not succeed. You will get into a panic state, and usually that leads to drowning. So don't try to swim against the current. Always go sideways and keep calm. So even if you don't have the strength to swim, just let yourself go. Don't try to give it the last push or whatever. Just buy time in that case. So what did we do? So we use Sentinel-2 images looking for sediment plumes. And I think if you really want to see this, I should have zoomed in a lot more. Sentinel-2 is a 10-meter resolution. We also got SuperView images from the Satellite Data Portal in the Netherlands. 2-meter resolution, and then you see all these beach morphology elements where you can actually see, okay, I want to see where there is structures perpendicular to the beach. Oh no, how do you say, orthogonal to the beach, in between sandbanks, and so it's a bit of a rule-based thing that then classifies, okay, where are all these conditions met. Yeah, so this is what I just tried to say more in detail. So there's a number of steps what we do. So first we test, okay, is something water or shore, classify accordingly, use a segmentation, etc. And then in the end you come to a riptide map. The second one is where we have to process these satellite images to sediment plumes, and then these are all these little green things here. These are the satellite sediment plumes. So this works easier for larger area where you can quickly identify the locations of active riptides. The recommendations out of that project were we need to build an improved AI relationship where we can validate much more data, because we only use the small set, and include in this relationship conditions of the beach, of wind, of the tides and the currents, because these riptides are not continuously active or have a continuous level of activity. And the second recommendation that we still want to look at is set up alarming systems based on the latest images, because as the morphology also changes, the locations of these riptides is not a constant, they will slowly move. Yeah. And I want to conclude with my team. And then there is some more information. I can share this presentation. I think that was also provided or at least mentioned. So I will also share this presentation. And I think then it's time for questions.
It is. Marnix, thank you very much for your presentation. Are there any questions from the participants? So if you don't feel comfortable speaking, put them in the chat. Also possible. Let me then kick off with a question. Marnix, you spoke about the Dutch coastline. From a global perspective, do you have any insights in how big the issue is about
Riptides.
rip?
Well, it is a global phenomenon. Most beaches do have these riptides. The mechanics are always the same. What can be different is the beach morphology or the type of sediments at the beach. If they can be detectable by looking at the plumes only, because not all the beaches have a lot of sediment transportation. Rocky beaches will be quite different. So I think whatever we develop to detect riptides, it will work at least at a lot of other places in the world. And also the danger, the risk is maybe even bigger abroad. I was a bit jokingly referring to the risk that tourists have in the Netherlands, because most Dutch people are aware of riptides, and are also, I might say, more than average capable swimmers. But in a lot of countries where how do you say, people are not that much used to swimming, it's even more dangerous.
Okay, so there is an opportunity for participants of the hackathon to develop some kind of technology and service,
Yep.
some kind of an early warning system or something would be, of course, a nice outcome to stimulate the participants even a bit more. We've organized the Cassini Hackathon. This is now for the third time, and we have a good standard to keep because in the previous editions, which we organized, once we had the European winner, and the second time we had the runner-up. So the stakes are quite high. So, but let then the story of Marnix and the business opportunity be an inspirational source for you. Okay. Are there any questions or considerations or ideas? Um, no. If not, then let's
Um,
go. Yeah.
Sorry, I have a question. Yeah, thanks for the presentation so far. Um, I'm not sure if this hackathon is gonna hold entirely on site. Like, is it provision for online participation as well?
No, the hackathon is on site this time.
Oh, okay, okay. All right, thank you.
So given the remark, I can say that we offer accommodation to participants who come from a bit further away or from abroad. So we can accommodate, but participants must be on site.
Oh, okay, thank you for the information.
Okay, good. Hope to see you around in Noordwijk. All right, then let's go to the next speaker, Friso. May I ask you to inform us about the Open Data Space Lab?
Yeah, thank you, Martijn. Let me share my screen. Can everyone see? Is that a yes, Martijn? All right. Hello, everyone. My name is Friso. I'm with the Open Data Space Lab, also called the ODL. And we made a marketplace for safe and decentralized data sharing that we want to use in this hackathon. And I just want to give you some background on it and see why it's useful. So I just want to go through a couple of things. First, I want to do sort of like what is the problem now with data sharing. Then I'll tell a little bit about what Open Data Space Lab is and how it works. And then I'll show shortly what it looks like. And then we can see how we can use this on the hackathon, and we can talk about the onboarding onto this platform. We'll all be pretty short, and I hope it's clear afterwards, but otherwise we can do questions. So first, what is the problem now? The problem now is that data is not being shared enough. There's huge amounts of data everywhere. Like, think about satellite data, drone imagery, things like that. But only a fraction of this is being shared. And then the question is why? The problem is that there's just a trust problem between two parties trying to share data. There's no control after you share data. So there's no, how would you say it? After you share this data with another partner, you completely lose the ownership. So if you want to know how the data is being used, or how long it's being used, or what the goal is of the data, you completely lose track of that. And that's a huge problem for a lot of organizations, especially the last point I made, but all three of them. And thirdly, I think how it works now, the data sharing depends on a central party. So if you think about, if you want to share a data set with someone now, you would put it on, I don't know, WeTransfer or something. You are very dependent on WeTransfer. If tomorrow WeTransfer changes their policies, you still have to, comply to those policies. So what is the result? The result is there's no efficient use of data sets and software. So what this means is a lot of times you see that the same data is being collected multiple times. So for example, with government organizations, will be 4 different government organizations trying to collect the same data set. Well, it would have just been way more efficient just to share this data set with each other. And the same goes for software. You see the same piece of software being developed multiple times. So what is the solution to this? This is Open Data Space Lab. Like I said in the beginning, Open Data Space Lab is a marketplace where you can share data in a safe and decentralized way. This is built upon a open source software. It's called dotSPACE, and this is a framework where there are 2 central things. First, the data always stays at the owner, and second of all, the data owner determines all rules and policies. So what that second point means is the data owner basically can decide like how long can the consumer use this data or software, what can it be used for, who has access, things like that. That's all things the data owner can control. So how this dotSPACE framework works, what it basically is it consists of ocean nodes. Ocean nodes is basically just a piece of software that runs on a server that is owned by the data owner. And these ocean nodes do a couple things. So it is, first of all, a gatekeeper for policies. So you have the data owner. If I want to, for example, sell a piece of software or data, I have my own place where I keep my policies and where my policies are enforced. So if I have a consumer trying to buy my data set, first people can see what my policies are. Like you can only use it for a week, and this is enforced on the ocean node. Second of all, this is the most important part of these ocean nodes, is that you can host computer data. What that means is that, for example, so this computer data is basically a completely contained environment to run software. So if you, for example, have an AI model that you want to train on my data set, this AI model comes to this ocean node. My data set comes to this ocean node. The AI model is trained with my data set, and then the results go back to the software owner, and my data set goes back to me without both parties having seen each other's data assets. And that is very nice because you can exchange things in a sort of trustless way. You don't have to worry about the fact that the other party is going to run away with my data, or I'm going to run away with their software. Third thing, so like I said in the beginning, this is a decentralized platform. So rules are enforced by smart contracts. So what happens, you basically onboard to this platform with a wallet, and then every transaction is logged on the blockchain. So that makes a sort of verifiable and immutable way to track all these transactions. Lastly, I don't know how many people are familiar, but Gaia X is integrated already in this platform, and Gaia X kind of provides a verification about the company that you have or that you're dealing with, as well as the data set. So it's basically a sort of like a stamp of quality. And this is already integrated on Pontus X. So, for example, you can choose that if you are selling a piece of data or a software or that you put on this platform, you can, for example, create your own policy that says only Gaia X verified people can buy my data set. So I know I'm dealing with a trusted party. So that's just another layer of trust. So ODL in practice, I just want to show you what it looks like on the website now. I'll just show you. So when you log on, this is kind of what you see. You see all these different data sets. You can buy it. Now you can see it. Since it's on the blockchain, we use Euro E, just a token, which is valueless, but you can buy these things with euros. This is basically how we're going to do it on this hackathon too. So I'll come into it in 1 minute, but we're gonna, for this hackathon, we're gonna have all these different data sets, and we just want to be able for you to access it at one place, and that place is going to be ODL. So you'll see something like this, you'll onboard, and you'll see something like this, and then during the hackathon, you can just pull all the data assets from here. So for the hackathon and the onboarding, we'll completely tailor a new platform like this to the hackathon, just so on our current platform ODL now, there's a lot of data sets about vessel detection and drone footage and stuff like that. We'll just make a completely new platform just for you to quickly grab all the data you need. So for example, for the MOU detection, for the riptide detection, those data sets will be there. So plus all the other use cases. You do need a wallet to onboard to this platform. I think in a couple days or next week, I'll make a complete sort of like list of all the things you have to do before the hackathon starts, just to onboard to the platform and stuff like that. Because you have to be verified to be on this platform. So I'll make a sort of how do you say it? Easy list of all the things you have to do. And then, in that document, you'll just see how to onboard to this platform, and then you can grab all your information from there. I think that's all I wanted to say, Martijn.
Thanks, Friso, for the explanation of the Open Data Space Lab. Let me have a look at the chat. No questions there. Maybe some live questions regarding the use of ODL.
Hi. I have a couple questions. Is it mandatory to use the ODL platform for the hackathon? And if we want to use other open source dataset that are not in the platform, are we allowed to do so?
The answer is no, it's not mandatory to use the ODL. But it is a facility which we offer to hackathon participants to to facilitate them in getting access to the relevant data sets. But you're free to choose other platforms as well. Marnix also mentioned like the Netherlands Satellite Data Portal, which is also there. So it's your hackathon. So if you think you should do it differently, then you're invited to challenge the system, of course. And the second question, Marnix, you raised your hand.
Yeah, what we discussed is that what we would do is put some test data, some usable data on the ODL platform as well, Sentinel-2 data and the very high resolution data of the Dutch coast. Because what we can do is make it analysis ready data. So you don't have to download level 1 or level 2 Sentinel data, but the data that we will put there is already completely atmospherically corrected and so forth. So that might help you to focus on the application and not on all the pre-processing or the data handling steps. But of course, if you don't want to use that, then that's your choice.
Okay, thanks for the addition to this. And could you please rephrase your second question, because
Yes, that's already covered because I am interested in using some data sets which may not be in the ODL or other platforms. So that, yeah, your answer covers that.
okay, yeah, okay, perfect. Okay, good. All right. Any other questions? If not, then let me say, and Friso already mentioned this, like the lack of data sharing based on the lack of trust. And for example, if you look at the market reports from USPA, and if you look at the market report from 10 years ago, data uptake was in those days a challenge and still is. So we came from far, but we have a long way to go, I would say. And federated systems for data sharing based on terms and conditions set by the yeah, and this is going to be the new standard based on the Gaia X, which Friso explained. So keep it in mind if you have if you're going to develop a new solution or product or service during the hackathon to base it on EU standards. If there are no further questions, and Friso, thanks for your contribution. Also, your slides will be shared and sent to the participants afterwards.
Martijn, sorry,
And
may I make the remark? As we also promised to participants the one slide pitch, 1 minute pitch slot. And
yeah, it's very good to have the moderator. So
yeah, indeed, during the registration, we promised, like not just promised, but we indicated that potential or existing participants can pitch themselves or their idea or the project in order to find the team. And I will send in the chat the list of 3 people that expressed their interest in pitching. I'm just not sure if everyone are there because usernames in Zoom can differ from the given names. And if you can see yourself from this list that I sent in the chat, please raise your hand and have your moment, 1 minute of shine.
yes, Kasia, thank you very much. So let me invite then Catherine.
Maybe she's not there.
No, if you don't participate, you cannot pitch. That's as simple as
Yes.
that. Then Trambak.
I saw Trambak here in the webinar, but maybe no longer in the webinar.
Okay. And then the last one, Mudit. Mudit.
Okay, not there, but maybe someone last minute want to tell about their ideas or find a team. Yeah.
I mean, go ahead.
Yeah.
Do I also get to share the screen? I don't think it's required, but
It is not required, but if you have anything to share, you can share.
yeah,
have-
or I just shared the link to the Taikai project over here. So I'm in touch with a few people already, other participants from Netherlands, and yeah, we're trying to come up with a team that's trying to do flood monitoring using Earth observation data, and yeah, it's a vague project still, but I want to use satellite missions such as SWAT mission from NASA and CONNES, which was launched only in 2023, so we have a couple years of healthy data already. And I want to work with machine learning techniques such as graph neural network. We're still looking for people to join the team, so I'm myself a hydrologist and with some background in geospatial science. We already have a couple people who are keen on using AI or working on 3D front-end development, etc. But if there are other people with complementary skills, maybe other hydrologists, geomorphologists, maybe business development experts, we're still open to add to the team. Yeah, thanks.
Thank you very much, Amin. So maybe some responses from other participants.
Or we just
Okay.
we can also share this link to the project in our email that we will send to participants that registered for the webinar, so maybe more people can react to that, and we can also share on Discord.
Yeah, thanks a lot.
Yeah, thank you.
Then, yeah, Discord, and it was mentioned, registration is mandatory, huh, for this hackathon. And yeah, keep also an eye on the Taikai page and on our own communications to provide you some last details about facilities which we offer. And yeah, that's more or less, in case there are no more questions or spontaneous pitches, which I had to say and which we wanted to present. So hope to see you all around in Noordwijk. Feel free to reach out in case of any questions. Could be about challenges, technology, data sets, but also about accommodation or dietary wishes or any other stuff. And then let me then thank the speakers for today. So Marnix and Friso, thanks very much. And yeah, looking forward to meet you all in Noordwijk. And of course, feel free to share all the links about registration pages and feel free to increase your teams, of course, and also invite others. So that's it from my side. So thank you very much. And oh yeah, one more last remark. The next webinar about the first challenge is next week. Same time, so also 4 o'clock. So, and then we have a speaker from NVWA and from the S&T. So see you then, and otherwise see you in Noordwijk. Thank you very much and enjoy your evening. Bye-bye.
Okay, thanks. Bye-bye.
Thanks. Bye.